We're good to go there. So it's time to open up MATLAB and get started. So last time, I believe we finished up chapter 3. Is that correct?
Quite finished it.
Not quite finished, maybe. Yeah, that's true. Possible. That's entirely possible. Let's see if we can't. Let's see, what do I do here? Let's share a screen here. Actually, that works. All right. This can go away somewhere. Here. Go away. Wish I could just get rid of this thing. I can. There we go. Okay, good. All right, so yeah, we're going to be, I guess, finishing up chapter 3. Let's see, where did we finish up? We finished up right around trigonometric functions, maybe? Does that sound right? We did trigonometric functions. Did we do data analysis, find max and min? I think we maybe talked about it, but maybe we didn't use it very much. Yeah, so we're right about page 79, I think, is where we ended up here. And we have just a few more things to learn here in section 3. Actually, we have quite a few quite a few things left, actually. But we're not going to. There's some things we're not going to cover, so we'll get through it anyway. We'll finish up chapter 3, and then chapter 4 is what? Functions, I believe, right? What is chapter 4? No, matrices. So chapter 4 is matrices. Chapter 4 is important, quite important, but we should be able to at least get started on it, maybe even finish it today as well. We'll see how it goes. In case you haven't realized it, the homework does have due dates on it, but they're not enforced in Blackboard, so you can turn things in after the due date. So don't worry if we're, here in work week 3 or 4 or whatever, and we're still doing homework from week 3 or week 2 or whatever. Just get it done and move on to the next one. But let's go ahead and talk about some of these data analysis functions. So maximum and minimum. If we have, we talked about this a little bit last time, but if you have a vector or an array or whatever that has a few numbers in it, doesn't matter how many, doesn't matter what order they're in, negative, positive, whatever, MATLAB can tell you what it can actually tell you what the max is. If the function is just max of x, tell you what it is. And if you have multiple rows in your array, for example, you go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and you do the same thing, max of x, excuse me, then what it's going to do is it's going to look at each column in the array and return the maximum for each one of those columns. So in the first column, of course, 1 is the max because it's the same number in each row of that column. And then so on and so forth. It just looks for each max. Notice that in this fifth column here, it chose 5 over negative 45 because negative numbers are less than positive numbers. So it does, and of course zeros are greater than negative numbers. You can also let's see. Oh, you can also use max to determine where the maximum is in your array. And so if you do max of x, it actually knows that it knows where it is, but you have to give it a place to put that number. And so what we do is we set an array of two variables that we have not used yet. We'll just use A and B. We haven't used those yet. And we make this array of variables A and B equal to max of x. And max x knows to return two values at that point. So we go ahead and hit enter. And what we find out is that what it first does, what it puts in the first variable for A, is it puts all the max numbers from the array. 1, 15, 48, 52, 5, 56. In the second variable, B, it puts in what row they're in each column. So in the first column, it's in the first row. In the second column, it's in the first row. Third column, first row. Fourth column, first row. But in the fifth column, it's in the second row. And in the sixth column, it's in the first row again. So it tells you what row it's in if you have multiple rows. Let's see, what else do we know with max? Do we use with max? Let's see. Okay, so the last part, sorry, I lost my place there, and my brain's a little fuzzy still from sickness and medicine. So our last max function here is the last use of the max function. You still do the max of something, but you can actually use multiple. You can actually do multiple things. Max of x and y. Of course, if we do this, we do need to have a y. So we're going to choose a y, but you have to know first how many elements your first matrix has. So we're going to find the max of two matrices. And remember, we had 6 by 2 here, so we need to make another one that's 6 by 2. Just like the last x, I'm just going to use that last one and replace it with y. Change some numbers. Make a new array. Maybe put a negative here. Maybe turn that into a 5. Maybe turn this into a 4. This into a negative 2. And a negative 15 and a 26 or something. And I'll do a 4 and a 5 and a 34 and an 85 and 5 and a 2 or something. Whatever. So I've got two different matrices now, an x and a y. And then I can do the max of xy, and let's see what happens. X comma y, I can do the maximum of two matrices. Well, let's see what happens. So what it's done here, and you can't really see x right now, so let's actually bring x up on the board first. So x is this, y is this, and this is max xy. So what it's done is it's gone term by term, and it's looked at the first row, first column, and said, what is the maximum number between these two? It's compared them. So between 1 and negative 1, which one's bigger? 1 is, and so in that spot, the first row, first column, it put a 1, and so on and so forth all the way through it. And it's created an array from the other two arrays that is the maximum from each array compared with the other array. And so that's another thing that max does. Of course, the max function can do many other things. And if you want to know more about it, you just go help max, and it will bring you to the help page for max, or the help data for max. There's another function called min, and it does just what you imagine, just the opposite of max. It finds the lowest numbers in these ways, and it has the same syntax. It uses the same kind of command structure as max. So there are two very simple ways that you can start looking at your data, maybe start sorting your data, finding things in your data, and in short, analyzing the data that you have or the information that you have. Okay, now let's go on to some statistics stuff. Page 82. We have the mean, the median, and the mode. If you're not sure what the three differences are, the mean is the normal average that you're used to taking, where you add all the numbers together that you have and divide by the number of numbers that you have, right? So we'll take x, for example. Let's see. Actually, we'll just change y. So we'll take y here, and we'll cut it down to a smaller array again. And we'll do the mean of this thing and see what happens. Mean of y gives us an answer of 2.833. And what it has done is it has added each term by term, it's added all the numbers in y and given us the mean of y. Well, what would happen if we took the mean of x? Because x is 2 rows, 2 columns. Let's see what happens. So what it's done here, if we go back and look at x, here's x right here. It's done again, it's gone column by column. So it has averaged the first column, 1 plus 1 divided by 2, which is 2 divided by 2, which is just 1, and it's given us an average. So it's given us averages here. So that's just the normal arithmetic mean, or the standard average that we always take. The median is different. So if we look at the median of x, the median of y, rather. Median. What the median does is this: it takes, and that's kind of a poor example. Let's change y really quick so we can make it a little bit better. So here's our new y. Now we're going to take the median of y. And the median of y is 4. And why is that? What the median does is it looks at all your numbers, and if you have an odd number of numbers, or an odd number in this row here, it takes the middle one. It just goes, there's 5 of them, I want the third one, right? If there's an odd number of numbers, it takes the middle one, and it returns the middle number. But it takes the middle number by value. So it actually lines them up in order of lowest number to highest number. So if I changed y here, for example, if I change what y is a little bit, instead of in this order 1, 2, 4, 6, 7, I have 2, 1, 7, 6, 4, right? What it's going to do is it's going to rearrange those numbers from lowest to highest and then give me the one that's in the middle just by counting. And so if I do the median, it'll still give me 4. It should anyway. So. However, if the number of values that you have in your box here is even now, and you take the median, then it gives you something different. And why is that? Well, the reason is because it's found the 2 numbers in the middle are now 2 and 4. And what it does is it takes those 2 numbers that are in the middle and it takes their mean, it takes their average, finds the number in between them. And that's what the median does. So the median finds that middle number. And of course, you can also take the median of a matrix that has more than one row. I'm going to have a hard time speaking for a long time today. And since this matrix X only has 2 rows, it just takes the average again. But if we gave X 3 rows, which I'm about to do, where is X? So if I give X another row here, one, 2, 3, 4, 5. So if I gave it 3 rows and then asked for its median, then it will just line up each row by order of, lowest to highest and take the middle one again. So in this case it's just 1, in this case it's 3, in this case it's the 5, and so on. So very simple stuff. And then the last thing is the mode. Excuse me. So if we do the mode of y, goodness, I can't type. This case, it gives us the answer of 0. Well, why is it? What is the mode? The mode is the most commonly repeated number. And you say, well, there is no commonly repeated number in here. That's true. When you have no commonly repeated number, it returns an answer of 0. However, if y was changed so that it had a repeated number in there somewhere, that's not what I want to do. So if I change this so that 4 is repeated, and then asked for the mode, dang it, can't seem to use my fingers today, then it tells you that 4 is the most repeated number. So that's your mean, median, and mode. The things that you use a lot when you're doing statistics. And then there are lots of other mathematical functions. There's the sum. So if I take the sum, and we take the sum of, let's see which one is sum of y, that's my one row thing. It adds up everything in the first row of y. But if I take the sum of x, you can probably guess what happens. It adds up each column and gives you sums for each of those columns. Once again, there's product, which does the same thing as sum except multiplies. There's what they call the cumulative sum. So if you do the cumulative sum of x instead of just the sum of x, what it does is it adds these things by column, but it adds the first one to nothing, and then it adds the first one to the second one and replaces the second row. Then it adds all three of them and puts it in the third row. And it does that all the way down each column. So the cumulative sum means you get the number that you had to begin with in the first row, first column. And then as you go down the column, you're adding the next element down that column to the previous one and replacing that element. And there's also a cumulative product that does the same thing with products, with multiplication. Now these can be extremely useful when you're doing things like counting techniques. Of course, you have the factorial that's also useful with counting techniques. But whenever you're doing things that require repetitive counting, repetitive multiplication, these things can be quite useful. Also, these things help you to build things like series, which we won't do much of in this class, but that's a very useful thing when you're using a computer to be able to calculate series of numbers. Let's see. All right, let's go now to the sorting functions. It's on page 85. Okay. Sort. Simple enough. What does it do? Sorts them in order of lowest, highest. Pretty simple, right? However, you can also do this. You can sort y and you can choose the command descend, but you have to put it in single quotes. So you can choose to descend, sort it in descending order, hit enter, and it'll sort from high to low, right? You can also sort rows. For this one, you need to have more than one row. So let's see what sort rows does to x. Actually, let's see what X is first. Let's remember what X is first so we can see what this does. Then we go to sort rows of X. What has it done? Now it says sort rows, but I like to think of it sorts it by column, but that's okay either way. But what it's going to do is it's going to go through and it's going to take each column and sort it by its from lowest to highest. And you can do the same thing descending. You can also let's see. So you can. I think you can actually sort columns too. Let's see that really quick. I think you can sort cols X. Let's see if that's true. No, that's not. And if there is, it's not the right function. There is a way to do it. The way you can definitely do it is you can just take the transpose of the function, so the rows become the columns come to the rows, and use sort rows. But I thought that they used to have one of those, and maybe they don't have it anymore, or maybe I'm just smoking something. But anyway, the other thing that you can do is you can actually sort the rows in a particular way using sort rows. So if I use sort rows of X, and I do comma 3, it actually will tell me that I'm going to sort this column. I'm going to sort this column on the basis, sort these rows on the basis of column 3. Column 3, is that right? Yeah. So let's see what happens when I sort rows in this way. So in this case we have, where was column 3? Where's X? Column 3 is this one right here, 4835, right? And let's see, what have we done here? Oh, yeah. So what this does is it actually chooses how it's going to sort it based on the value that was in the first value in the column. So if I go out here to let's see, if I go out here to each column, this one's positive, 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 but this one's negative. So for all the positive ones, it's going to go from low to high. For the negative one, it's going to go from high to low as it sorts it. And I'm not sure what it did in the last one, actually, because that one's supposed to be, let's see. Oh, here's the right one. I'm looking at the wrong one. No, I'm not. I'm looking at the right one. Sort row of X3. Yeah, so these are supposed to be in I don't know what it did here. This is kind of goofy. It's not supposed to do that. In that last column, or in that second to last column. Sort rows should go from lowest to highest. Huh. Something goofy happened. Let's go see what this has done. So I'm going to look at help sort rows. So sort rows sorts rows in ascending order. So from the lowest number to highest number. complex we don't care about, but what if it's negative? If you do by a specific column, if the column is positive, the corresponding column will be sorted in ascending order. If the column is negative, of course, it will be sorted in descending order. And that's what I thought it did, but that's not what I'm seeing it do. Oh, if any element of the column is, if an element of the column, the corresponding column is X. Oh, I see what's done. So it looks like what it did is it took I'm still not entirely sure why this last one went from 6 to 4 to 56. That's confusing me. But when it looked at this one and it saw the negative 45, it did sort it in descending order.
60.
The other ones were in ascending order. I'm not sure why this one did this though.
If you look on page 86, it shows has skaters, their time in a race, and if you order based on that, then it puts them.
Oh yes, that's right. I remember now. So I see what you're saying. Yes. So whenever you do, whenever you specify a column, that means the first row stays where it is, right? And I didn't see that because the first row is the lowest number in every case except for these last two cases, right? But with the last two cases, I had a negative 45 to start, and so it put that one in descending order from 2 to negative 45. So in other words, it doesn't sort the first row if you specify which column you want to come from. So thank you for pointing that out. I'd forgotten about that feature. And that's exactly what it's for, is in case you want to keep a row, if you want to keep a particular row intact, so for example, a particular row is the number of a player, number of a skater or whatever, then you can actually choose to keep that one where it is, and then choose whatever row you want, whatever column you want to base your things on. So yeah, we will see an example of that. That's good that you saw that. Thank you. Like I said, I am not an avid programmer, so I often forget these details. Okay, so let's actually go right to that example, because that will give us a nice example of how this works here. That's on page 86, right in the middle. They give us this table of data. I'm going to go ahead and clear off my screen, clear my variables, start over. And we're going to have these results. Are going to be this. They're going to go ahead and use a column array. So you can do it any way you want. You can do the 1, 2, and then sorry. You do the 1, 68.89, and then your next row. Oops, something wrong here. And then your next row is 2 and 68.74. And your next row is 3 and 68.86. Hopefully you can understand me. I know my voice is all slurred because my sickness here. 4 is 68.39. Dang it, why did it do that? 68.39. And 5 is 68.43. So we get our two columns here, and that's good. And what we're looking to do is to use the sort rows function to sort in descending order the scores or the times, but not to separate, not to change these sorts, these ones here. So we want to, yeah, in descending order. So if we did descending order, oh, well, what we want to do is we want to make sure that these numbers stay with these numbers, right? We want to make sure that the number of the player stays with the number of the time. So if we just do sort rows, let's see what happens. Sort rows of skate results. And we see that the 1 stayed with 68.89, and the 2 was 68.74, and the 3 was 68.86. The 4 is 68.39. Nothing happened, right? Why did nothing happen? Because it's actually, well, because it's sorting by row by row, essentially. Why is it doing that? But anyway. So let's try now.
It descended from 1 to 5.
Yep. So now we'll try the descending, right? We'll try this step by step here. I can hardly even keep track of my thoughts here. So we're doing sort rows now descend, not descending. Goodness gracious. And we want to do this by, did I do that right? Nope. There we go. So let's see what happened now. What happened now is it sorted these things 5 to 1 here and 6.89 to 6.39 here. This is actually what I was trying to do on the first one. But it separated the number of the player or number of the skater from their time. Right? 5 actually got a 68.43, not a 68.89. So this is no good. This is not what we want to happen. We want to be able to sort this so that we don't lose which skater goes with which time. Right? So what do? So we can use the sort rows function, which is exactly what they're doing at the top of page whatever, 87. Yeah. So we're going to go ahead and do sort rows, and we're going to do skating results. Skating results. Results. Okay. And we're going to do this. We're going to only sort. The only things that we're going to sort, or the column that we're going to sort by, is going to be the second column. So we put a 2 in there. What that tells us is it tells it to sort the second column, but to keep the first column in line with their numbers from the second column. But what we can also do is we can also put a negative on here, and that will tell it to do it in descending order. Because sort rows doesn't have the descending order, as we just realized up there. Didn't like that. Why not?
It should just be skate results rather than skating results.
Yeah, again, my brain is a little fuzzy. Thank you. So now we've kept our numbers with our scores, right?
Yeah.
So 1 was 68.89, it's still 68.89. 3 was 68.86, it still is, so we're happy now. So that's where we were. Okay, sorting functions. And in all these functions that I'm giving you, there are many, many more. There are variations on these things. There are many other functions that do these things. You can do these many different ways. What we're trying to give you here is just a starter. So if you find another function that does this, does it better or makes more sense to you, go to your weekly function shared document and enter that in. Share it with the rest of us. Okay, so bottom of page 87 now we have some other functions having to do with finding the size of arrays. For example, if I do size of y, oh, y is not in there anymore. We need to make a new thing. So let's make a new x equals the array. Oh, let's do a nice one. X equals 1 to 1 by steps of 0, 1 to let's do 7. Let's do steps of 0, 3 to 7. Why not? That's going to make a huge array, but I don't know how big it is yet because I'm trying not to look at my workspace. But then I take the size function and I do the size of x, and it'll tell me. The first thing that it returns is the number of rows. The second one that it returns, second number, is the number of columns. So this is a 1 by 201 array of numbers. If I have an array of, let's make another one like this. Let's do a y equals -1 to the -7. Make another array. And then I make an array that is x comma y. We're going to combine those two arrays. Oh, I need to name that something. Or I can just ask the size of this. What's the size of this thing? I think it'll do that. So that one is 1 by 402. We just put those two things right in a line. What does that mean? The answer was this. What it did when I put those one right after the other is it just put one. Whoa, that's not what I wanted. When I put these things right next to each other, like this in an array, then it made this array. It put the first array in this nice long row, and then at the end of that row, or halfway between that row, it added the next ones from that array. So I just put them right one after the other. So that's a 1 by, and maybe that's not what I wanted. Maybe I'm asking what the size is. I didn't want to put them next to each other. So let's say I just didn't remember how this would work, so now I know how it's going to work. I need to put them next to each other in one row after the other. In other words, I need to make two columns. In other words. So I go ahead and do that, and then I can ask what the size of this thing is. Size of the of this XY thing. So when you're doing very complex stuff with arrays, these can be useful to figure out what you've done, or to oops. I keep putting that semicolon afterwards. This is saying this. Oh, that's the wrong. I put the semicolon in the wrong place. It needs to go right there. There we go. So now it's showing me that this thing is a 2 by 201 array, and now I know that's what I wanted, because I wanted to put one of those arrays in the first row, the other one in the second row. This has two rows with 201 columns, and I know that I've done it correct. Now for the simple ones like this, it's not that hard to just look over here, but when you're doing really complex stuff, it's kind of useful. And it also sometimes is, these numbers are sometimes numbers that you will use in your program. So if you're doing a program where you need to use the number of elements in your array in a calculation, then this is a way to get the number of elements in that array. Okay, so that's size. Then there's length x. So instead of size x, we use this length. What length does is it's similar to the size, but it only returns one number. And if your array only has one dimension, if it only has a row or a column and not really both, then it just tells you how long that row is or how long that column is. So if it's a 1 by 201 like y is, then that's fine. However, if you're doing the length of an array that is like this, where you have x comma y, well, this one will give you a very similar thing because remember x comma y gave us just a really long array. But if we do this x semicolon y, then it will return just the 201. So it returns the greater of the two dimensions if it's a multi-dimensional array. So that's what length does for you. It returns the largest dimension in your array. And then there's one other one that will actually tell you the total number of the elements. So it takes the rows times the columns, and it's called the num_el, so number of elements, right? And we can do this one again. X, Y, right? And it's going to count them all up. There were 201 in the first row, 201 in the second row, for a total of 402 elements in your array. Pretty straightforward stuff. Excuse me. So, in this example 3.3, we have a bunch of weather data from different days in different months in North Carolina. And one of the things that they'd like to be able to do is to add up some of this data. So this is all rainfall, I guess, precipitation. And they want to add up the amount of rainfall that is in this table of data. Let me see if they actually have weather data. They do. Weather data, where is it? Okay, so this weather data file may be available in MATLAB, but I don't think it is. I think we have to go get it from the website for this book, which may take a while. Let's just check to see if we can pull it up here. I don't think so. Yeah. Let me check another place really quick. Don't have it there either. So I'm going to say that we don't have access to it very easily. But anyway, you could get, you can get files of data, and you can import different types of files like Excel files and text files and other things. And then you can use that data. When you're importing a text file like this with data in it, you often have no idea how many rows and columns it has. You often are just given this thing of data, and they're saying, we took some data over some time, some amount of time. We don't know how long we took it for, or we don't remember or we don't care. We're just giving you this data. Now you need to analyze it. And so that's one of the places where it's very useful to start knowing how big that data set is, how big that array is of data. But the other thing that you might use it for is that you might use some of these tools for is to find the maximum rainfall and what day that was on. Because remember that max can return both the maximum number and the location of that number. But you can also take averages, and if you know the size of your array, and you know that columns represent days and rows represent months or something like this, then you can actually start to extract specific days from the calendar for the data for that day from the calendar, and then you can average several days together. And in this example, they don't do a lot of that. They do a yearly total, and they do a yearly average, and they do a yearly maximum, the maximum of the year, and all this stuff. And that's stuff that's pretty straightforward. But later on, we'll learn how we can look at just a piece of the data. So I just want to see the average for January, the mean of January. I just want to see the average on this day in February, or whatever else, for these 5 days in February. And as we get into chapter 4, we will see how that can be done by playing around with our matrix and understanding how the matrices can be manipulated. Okay. Variance and standard deviation. We're not going to do anything with variance and standard deviation, and since we don't have any math requirement for this class, I'm not going to get into statistics, heavy statistics with you. And so that means we're just going to move on from the 3.5 into 3.6, where we're going to give you the last, I think these are the last ones in this chapter. No, they're not quite. Still have a few more. But we're not going to actually do the next section either, so, because the next section has to do with complex numbers, which we're also not going to make you work with. Not that those things aren't important, they are important, but because we don't require any prerequisites for this class, we try to keep the math at a kind of intermediate algebra at most. But here on page 99, we get our next taste of some functions that are built into MATLAB. And these are random number generators. And this can be very useful, particularly when you're trying to simulate things in nature and you need just a random number to put into the simulation. This includes everything from biological systems of growing bacteria or something to playing cards. All of these kinds of systems are essentially life systems. Systems that have a fair amount of randomness to them. And so to be able to create these is quite nice. The random number generators of MATLAB generate random numbers very similarly to every other computer random number generator. And that is they have an algorithm, which is like a mathematical function that extracts a number or multiple numbers from the computer hardware. For example, in the computer hardware, there's a clock that's ticking away. In the computer hardware, there's memory that's being stored. And all those things are just numbers to the computer. And so what the random number generator does is it goes out and grabs one of those numbers at any given time, and it is a random number because it grabs it at a random time, and those numbers are always changing. And then if you grab that random number at that random time, or random numbers, and then plug them into this formula, it actually creates another random number. So and that algorithm actually may choose to make it positive or negative, or may choose to round it up to an even number and then multiply it by 7 and subtract 38.4 or whatever else. So there's all kinds of randomness built into it to try to create these random numbers. There's kind of a group of computer junkies that are just dedicated to creating random things in computers because it's so important. The first one on page 99 is just the normal one, the rand number. And what it's going to do is it's going to create a matrix of random numbers, whatever size you ask it to make. And so if I do rand 1, it's going to make a matrix that is a 1 by 1 matrix. In other words, it's going to have one column and one row, and it's going to put a random number in there from the random number generator in MATLAB. If I do the same thing with rand 2, it gives me a 2 by 2 matrix. So it gives me 4 numbers total. And of course, you can keep doing that for any integer, any positive integer you want, and it'll create those matrices. However, if I do a rand 2 comma 5, you can guess what it does. So this is also very useful that it allows you to build matrices very quickly of random numbers, because if you have a whole bunch of pieces of data and you need to multiply them all by a different random number, and that data is in a matrix, then you can create a similar matrix to add or subtract or multiply or whatever your random numbers with. And each one of these is a unique random number. So here's another one, another function, rand n. So why is this any different? This one creates a random number which is on a Gaussian or a sometimes called a bell curve kind of scale. So in this case, if you look at a Gaussian curve, let's go to Google really quick. Gaussian. So the Gaussian bell curve, as it is often called, is what we call in mathematics a normal distribution. Two of the things that are characteristic about a normal or Gaussian distribution is that the average is always sitting right on 0. That's one thing. And that your curve here tails off as it goes out towards positive infinity and negative infinity. So what they're saying here is that they're giving you a number from somewhere in here, but the more likely numbers to be chosen are these ones, and the less likely numbers to be chosen are out here. So it's a different kind of random number generator that chooses numbers based on some statistical probabilities. So that's the rand n, or rand for rand normal. And then, of course, you can create matrices of different sizes with that as well. Also, forgot to mention that the random numbers for just the regular random number generator, you may notice that they're all positive, because it always does make a positive one. And also, it's always a number between 0 and 1. So if you need a number between 0 and 10 for the random number generator here, you just take rand 2 and you multiply it by 10. And you'll get numbers between 0 and 10. Or whatever. If you need it between 0 and negative 10, you do 0 and negative 10. So that's that. Random number generators. Now, here's one that we can actually do. So let's do a problem here, because this file is available to us. I'm going to load in a file that is available in MATLAB here, and this is a this is actually a music data file. So once we load it, we can actually play it. There's this function called sound, and we're going to sound, let's see, did we do this right? Yeah. Sound Y, and we don't use this very often, and I don't think I've ever really used it except to demonstrate this, so I don't know all the syntax for this, but this should work. So it plays the Hallelujah chorus, right? And I can actually pause it just like I can pause anything. Hit pause and it'll wait for me to hit another key, so I hit my space bar, and it should play. Didn't. It didn't let me do it. But anyway, it stopped it. So apparently if you pause it, it will stop it. And that's fine. But what we want to do is we want to add some random noise to it. So what we're going to do is we're going to create some noise that has the same size as this handle matrix. Because this handle matrix is just this thing. Let's open it up. It's just a set of numbers. Okay? And MATLAB understands what those numbers do when you use the sound function. To us, it's just a list of numbers. So we can actually do some randomness. Let's do some randomness here, and let's build some noise into this. Noise equals, and we're going to use the normalization random because we want to have some positive and negative noise. But we want the length of our random function to be the same length as y was. So the same length as y, and we want it to be just one column like y was as well. So one column, but as many rows as y had. And we're going to multiply this random number thing that we're generating by 0.10, which will give it a little bit of volume. Then we'll suppress the output and hit enter. And then we'll do our sound thing again. And we'll sound now y plus noise. We can add these two things together and create a new sound. See what it does for us. So that's why we didn't hear it when we hit pause, because it's not very long. But have you ever wondered what static is? So if you're listening to the radio and there's static, or you're watching television and there's static, what that is it's random electromagnetic noise on the signal coming into your TV or radio or whatever else. That's all it is. It's just random electromagnetic waves that are added on top of the actual sound waves you're trying to listen to or watch or whatever else. So one of the things that they do to clean up that noise is they use digital signals, because digital signals are very easy to distinguish from background noise. Background noise literally looks just like noisy waves, just messy waves. But digital signals are very square, very, very distinct. So if you use digital, you can easily pick it out. You can easily pull it out. It's not as true to the original sound, but it is going to be free from noise. And so that's one way to do that. Let's see, what are they doing here? Recording. Oh, in the last part they plotted out, actually. That's fine, let's plot it out. Let's do that for fun. So we're gonna make another array. Actually, you know what I'm gonna do? I'm gonna take a break here for a few minutes, and we'll come back and do this. So we'll take our 5-minute break right now.
Take a break. No, 1 to 5. I borrow one. Well, I mean, I gotta go get it. Okay, can I borrow one of this? Watching. I know, it's fun. You guys like what you did? What? You have a book yet? The book in from my book. They're going to do my all my homework to do some. Have you done it all? How hard?
It's easy. It's just boring, pointless kind of.
What do you think you're good at?
What's your first assignment?
Tuesday, Thursdays. Yeah, but you could go home and make lunch. I gotta scrounge up something. Not fixing this. There's no talk in the coffee. You're in March. Mm-hmm. 30 minutes. About 20 minutes south of it. Probably one. I can make it 6 hours. Slower. We get better gas. Slower. This is slow. It's only slower by 30 minutes. It's shorter by 20 miles. 25 miles. This takes about a minute. You're even here still. You're here. the chapter 4. Not sure if you know Pepsi. Do you like Pepsi better Coke?
I like them both.
I like them both. I prefer Pepsi.
Well, I prefer Pepsi over Coke because I like Mountain Dew.
You like Mountain Dew?
There's a reason weird.
Oh, dang.
That's
They don't have it. Yeah, they do.
Okay, you guys ready to get going again? All right, where were we? Oh, yeah. We're going to plot this stuff. So in order to plot, you have to have a bunch of points for X and a bunch of points for Y. We already have our points for Y right here in our workspace. That's the file that is the actual sound. And we have our points that are noise. Those are also going to be Y points, the vertical axis points. But we need a set of numbers that's going to put these in the right order on the x-axis. It's going to organize them into two-dimensional space, into a wave. So we need to create that. We're going to call that a time array for T. We're going to have timestamp for each one of these numbers that's in this array. So T is going to start at 1. So it's going to go 1. And it's going to go all the way, just stepping 1, 2, 3, 4, 5, so on and so forth, all the way up to the length. So we're using our length function now of Y. And now T is going to be another array that just goes from 1 in order up to the max number of elements in Y, so we can use it to do our graphing. I'm going to go ahead and suppress that, and we should get a T over here that's the same size. So we have it's a 1 by 73113 double, and the other one is a 73113 by 1 double. So they're the same size. Well, they both have the same number of elements. They're not necessarily quote unquote the same size, because one of them is 1 row and many columns. The other one is many columns in 1 row. But that's okay. So they're going to create. They want us to create a new addition of these things where noisy is equal to Y plus the noise. Right? So we do that. Just creates a combined file, or combined values, I guess, in one array. And then what we're going to do is we're going to plot the time and the Y. So time on the x-axis, Y on the y-axis, and then the time and the noisy together. So in other words, we're going to plot the sound and the noisy sound together. So plot T and Y. Is that what we're doing? We're plotting t and y. Oh, they're only doing, but they're, so one of the things that we haven't taught you yet, but they're going to use right now, is we're going to only plot some of each of these. Since these things are so long, you know, they're 70,000 points long. We're only going to plot part of them. So we're going to plot from 1 to 200. We're going to plot 1 comma 1 to 200. So we're going to plot the first row and 1 through 200 of the second row. Or sorry, we're going to plot the first row and we're going to plot 1 to 200 elements. One from element 1 to element 200. Sorry, there we go. Now I've got it. We're going to do the same thing for y, just to shorten it up so that we're not plotting so many points. Y, and then when you're doing y, since it's many rows in one column, we'll do it backwards. So it'll be y 1 to 200, comma 1, like that. So then we do the same thing in t for our t. Sorry, same thing for the second half of this for t and noisy. I'm just going to copy this really quick. Put it out here. So when you're plotting in MATLAB, you can do multiple plots in the same command. It knows how to do that. It knows that the first thing in each pair is the x-axis, the second thing in each pair is the y-axis, and it just keeps doing that. In this one, I'm going to change my y to noisy. So just as a review of what I've done, that is a little different than we've seen, something new, I'm plotting the time array, first row, 1 to 200 of the column, 1 to 200 of that column. So the first 200 elements. And then I do in y, I'm doing 1 to 200, the 1 to 200 rows in the first column because it's a one column thing. And I do the same thing in t again, and then the same thing in noisy again. And then I close off the plot at the end like that. And I go ahead and hit enter, and it brings up a plot. And there it is. So the first thing, the blue one, which is the default color, is the wave that represents Handel's Hallelujah Chorus. This other one is Handel's Hallelujah Chorus plus the noise we added in, plus the randomness we added in. So that's what it does. Notice that it follows. It follows Handel's Hallelujah Chorus, but sometimes it peaks above it, sometimes it spikes below it, but it generally follows it. Right here, it follows it really cleanly, but only for a very, very short amount of time. This right here is like a very small fraction of a second. So that's what it looks like. And of course, you can go ahead and label these if you want. I'm not going to label them, but like they do in the book. So that is an interesting use of that random number, and also a nice little use of the length function and other things. This next section, 3.7, covers complex numbers, complex computations, so we're not going to deal with that. We're not going to expect you to know how to deal with complex numbers. And then computational limitations is this next section here, 3.8. Excuse me. MATLAB does have limitations. Unfortunately, sometimes when you reach those limitations, MATLAB will just freeze. That does happen sometimes, and you just have to shut it down. But let's take a look at two new functions here. RealMax tells us the largest possible number that you can make. They call it a floating point number. So a floating point number being something that essentially is not an integer, something that is fractional or decimal, some whatever. But the largest floating point you can get to is this 1.7977, and of course that's not exact, there's other numbers in it, and an e to the 308. Okay, so that's a pretty big number. Then there's the real min, Tells you the smallest number you can get to. You did a minus 308. You got a wide range to work with. When it comes to integers, it's a little bit different. Integer max, that tells you that the largest integer you can deal with is a much smaller number than the largest real number you can deal with. So, you have different limitations whether you're using integers or floating point numbers or real numbers. And I believe that the reason for that is, I believe that the reason that they're different is because MATLAB does integer math differently, and it also stores real numbers or floating point numbers differently. So your floating point numbers are often truncated and shown as an approximate number. So they can actually store it using kind of a little algorithm. Whereas integers have to be stored exactly because they are exact numbers. So it takes up more space to store that exact number rather than an approximated number. Let's do they do a little bit of math to show what happens if you overdo it in MATLAB here. So if you have 2.5 e to the 200, which is 2.5 times 10 to the 200, right here. So it's 2.5 times 10 to the 200. And if you have y, which is, if you multiply that answer times another number, times, good night, times 1 e to the 200. MATLAB doesn't know what to do with it. It just gives you back infinity. So whenever you get over that e to the 308 number, it just doesn't know what to do with it. Calls it infinity and you're good to go. Gotta be out, gotta do something else. If you divide a number by 0, you also get infinity because it's the same thing. Doesn't know what to do with it. And if you reach the minimum while you're doing calculations, it will return 0. So the minimum number is a number that is very close to 0. And if you go past that, it will just return 0. Now that's for the real min, right? The real minimum. The integer minimum is actually a negative number. So the integer minimum, if you're dealing with integers, is a very different thing. But if you just most of your math in this class will be real numbers, will be floating point numbers. So your minimum will be essentially, if you go too close to 0, it'll just round it to 0 and call it good. Okay, let's see. So here on page 108, there's a really good example of something that could go wrong. But if you reorder it, if you rearrange your calculations, you can make sure that it doesn't. So you've got this 2.5 times 10 to the 200, 2.5 times 10 to the 200. Well, those two things multiplied together will give you an overflow. It'll give you infinity. However, the next thing is multiplied by 1 times 10 to the minus 100. If you put that one second, MATLAB will do that number second. And then you'll get 2.5 times 10 to the 200 times 1 times 10 to the minus 100. And you'll stay within the overflow. And the math will come out. So MATLAB does work from left to right, except when there's an order of operations in the mix. If there's some parentheses in the mix, or if there's a multiplication after an add, an addition or subtraction, or a division after an addition or subtraction, or a power after an addition or subtraction, then it'll do those things first. So look at the order of operations and see if you can rearrange them without changing the actual calculation in such a way that you never overflow that maximum or minimum. underflow, the minimum, overflow, the maximum. So that's a nice little tip or trick for dealing with the maximum and minimum. Okay, special values and miscellaneous functions. Page 109, there's just a list of them. My voice is just given out here. But we have pi, which we've already seen. For imaginary numbers, you can use capital I or capital J, which we're not going to mess with. Infinity, we've already seen. If MATLAB returns NaN, it means that the calculation does not return a number. Okay? There's also this function, the clock function. Type in clock, and it'll give you the numbers off the clock. They may not mean anything to you, but to the computer it tells the time and the date. And it actually should mean something to you if you look very closely. 2018, that is the year. 0.0010 is the month, so that's January. 0.0310 is the time in military time. No, it's not.
That's the day. Month, day.
Oh yeah, that's the day. Sorry, I missed day. Thank you.
13 is the hour.
Yep. This next one here is the time in military time. And that's the hour in military time. This one is the minutes, and this one is the seconds. And that's taken from the clock on your computer. So it's just this list of numbers. If you look at the binary code, it's much more random looking, or the ASCII code than the binary code, then it's much more random. But so if MATLAB takes numbers from this for its random number generator, it may take it at a particular time of the day. It may take this number and plug them into a algorithm, or it might take this number and this number, depending on the time and the day and the week and whatever else. So it has many things built into it to create as random a number as possible for the random number generator.
You type that fixed clock, it'll put it actually what's supposed to be.
This right here.
Actually, clock has to be in parentheses.
Like that. I've not seen this before. Oh, very nice. So I've not seen that before, but that's kind of cool too. Like that. Then there's the date function. Gives you the date. Just answers it as a, day, month, year thing. And you can actually, And then you have this EPS function, which gives you the distance between one and the next larger double precision floating point number. Nice. What does that mean? I'll tell you what that means. So what this means is, this tells you essentially the precision that MATLAB can calculate something to. So the precision with which its calculations are presented to you when you're done can be as small as 2.22 times 10 to the minus 16. In case you're wondering what that means. Okay, so we're done with the chapter. The nice thing about this chapter and many of the chapters is that you have this summary at the end, and this one's rather long because it shows you a whole bunch of functions that we learned here in this chapter, and there's a lot of them. But that can be a nice little reference for you. Of course, I usually just use everything that's in MATLAB, and that's fine for me. I'm not sure if my voice will last much longer, but we can go ahead and try to work through some of the things in chapter 4. It's not necessarily difficult, chapter 4 or anything. It's just my voice that we're worried about. Chapter 4 is all about learning how to work with matrices how to extract things from them, how to put things in them, how to figure out what is in a matrix, particularly in particular points and spaces, changing them somewhat, things like this. So let's see if we can get through this, the first section at the very least, and see how my voice is doing after that. My voice doesn't hurt yet, so that's a good thing. So anyway, we've already built matrices, and so we're not going to try to do any of that. They do that for the first page here. I showed you this at one point. You may not remember it, but when you're in the let's see. I don't know if you can do this in the command window. I don't think you can, but let's try it anyway. If you're in the command window, you can create a column matrix two different ways. You can put in your number and the semicolon for like that, and that creates a column matrix. There we go. Or there is another way to do it, if I can, there we go. So I think I've shown you this before, where you hit enter before you put in your closing square bracket, and then you hit enter again, and then you put in your closing square bracket, and you can do it that way. Some people like to do, to make it a little bit cleaner, they like to do A equals, open your square bracket. Yeah, dang it. Then hit return and then hit tab or spaces like this. Tab doesn't work, but spaces do. And then space over to hit your next one. They like to do it that way sometimes, just because it looks a little cleaner or whatever. It's up to you how you want to do it. I prefer to just put in semicolons. It seems faster to me. Of course, the other way to do it is to define your matrix, define a matrix B equals 1, 12, 23, or whatever else, and then put a little asterisk after it, or single quote or whatever, and we'll turn it into a column matrix. So that's what we call transposing the matrix. It turns rows into columns and columns into rows. It'll work for any size matrix. So that is that. Let's see. Oh yeah, okay, so now let's go down the middle of page 120, I guess where we're at. So we're going to do what we call concatenating, I believe it's what they call this. We define a matrix B to equal, well, we already have a matrix B, that's fine. So now we're going to define our matrix S to equal, we're going to create a matrix here, and we're going to put a value in. Let's put a value of 5 in. And after that value of 5, we're going to put in B. So we're going to add it on. We're going to add on the matrix B to the end of this other thing and see what happens. So it puts in 5 in the first row, and then it puts in the next rows for B. The next rows are just the rows of B in this single column. And if we had a matrix C, and it was equal to a row, we could do the same thing. Whatever. Right? We could make a matrix D that was equal to, and you can do this in pretty much any order. You could add some, you could put something at the beginning, 34, and then put a comma and put in C, concatenate C in there and concatenate something else on the end of it, 67, and it will put something on the beginning, put C in the middle, and 67 on the end. So this is one thing that you can do with matrices, is you can add in, subtract out. Now it starts to become a little more complicated when you have matrices that have rows and columns. So so let's go ahead and make something like that. Let's do matrix A. Oh, let's see. Do they do one here, or am I? They don't really do one, so I'll just do it. I'll do one of my own. I always get sidetracked doing examples of my own and then find that they've done one in the book that I should have done, so you can see it in the book and on the screen. But anyway, we'll make a matrix A, and I'm going to make this matrix A a little bit differently now. I'm going to say A is equal to just an open matrix so that it comes up blank. And I'm just going to open it up here and make it in here. So I'll do a 45, click on that, do a 45, do a 4, do a 12, do a -5, go down here and do another 12, and over here and do a 2, and here and do a 1, labeled 0, do a -8, and a -7, and a 56, and a 0, and I'll do that's it, we'll call it good. So I'll close that. I've got a 3x4 matrix, which is A. So now if I type in A, it gives me that 3x4 matrix back. But let's say that I want to put another row on there. I can do another row, but I have to remember what are rows and what are columns in a matrix. So I'm going to do B is going to equal, and remember when I put in things with columns in it, I got a column, a column, a column in one row, right? If I put in semicolons, then I got a bunch of rows with one column. So I want to add something at the end of this that is an entire row at the end of this. So how am I going to do that? It's, this could get a little tricky. Well, how I'm going to do it is I'm just going to try it both ways and see what happens. Okay, so B is going to equal, now I'm going to put in a row of numbers, 1, 2, 3, 4, and then I'm going to put in B or A at the end of that and see what happens. Let's see what happens. So I put in 1, 2, 3, 4, and I put A at the end of it, and look, it gave me a row, and then it gave me all the rest of the rows after that. So that worked out nicely. If I wanted to do this A at the beginning of it, how would I do it? I would do A and then a new row and put it in. But what if I'd chosen the wrong thing? What if I'd done A, comma? Let's see what happens. It doesn't like it, because what this is doing is it's taking the A matrix and it's adding a row to the end of the first row of that matrix. And so it's concatenated only one row. It doesn't like to do that because I haven't told it what I'm going to add onto the other rows. It's confused. It wants something that the dimensions are going to agree, so that I'm telling what to do at the end of each thing. And the same thing goes for if I did A, comma, 1, semicolon, 2, well, actually this may work, actually. Let's see what happens if this happens. Nope, doesn't like that either. Let's try this. Let's put a semicolon everywhere. See what happens. Doesn't like that either. So concatenations, you have to be very careful the way you do them. So you have to know what you're adding on. When I did this first one, I made a row, and then I added on these other 4 rows right after it. So this is a row, and this is a matrix of 4 rows that are 3 rows that are each 4 wide. So this row is 4 columns wide, and this is also 4 columns wide. So the columns have to match. 1 row, 4 columns, 4 rows, 4 columns. The columns have to match. Okay, so that's concatenation. It's confusing, but useful. Okay, what else do they do here? Nothing else really. Okay, so now let's mess around with this matrix. They're using a different matrix to do this, a much smaller one. I'm just going to use B since it's up there. If I want to know what value I have in here somewhere, in this particular matrix, I can choose an index. So B1 is equal to what? 1. So that's the first value in B. What's the second value in B? Let's see what it is. B parentheses 2 will give me the second element of B. But what is it going to be? Turns out it's 45. So what this does is it goes down the columns one at a time. Now we've seen that before, right? We've seen how MATLAB likes to go down columns first and then by rows. Don't ask me why. I don't know why, but it just does. So the next one, B3 would be 0, B4 would be negative 8. What would be, what number would be B9? That's right. It would be 3, right? You go down 1, 2, 3, 4, 5, 6, 7, 8, 9. However, there's another way to do this. Can anybody guess what value this is going to be? B, parentheses, 3, comma, 4. What is that going to be? Can you guess?
There's a number. Well,
So we have a guess for 12. Why did you come to that conclusion? Because the first one is the row, the next number is the column, 312, right? Or 34 takes us to a value of 12. Let's see if you're right. You are right. So you can actually extract it either by knowing which number it is, which is kind of crazy if you have, multiple dimension array. Rarely do you use that. You do sometimes use it, but I think this one becomes more useful because most of the time when we're arranging things in an array, we're organizing them in some way by column and row, so it just makes sense. But that allows you to extract a single value, and you can actually assign it to something. You can say A equals B, capital B, there we go, 2, 3, comma, 1. And that will say that A is now equal to 0 because that value in the third row, first column, third row, 2, 3, first column is 0, right? So then now A is equal to 0. A is equal to that thing, and then you can use it as a variable in an equation or in a function or something else. So this is very useful, very powerful. I have to take a really quick break because I just got a phone call from somebody that I have to call back. I have to make a purchase. Well, actually, now that I think about it, I can't do that. So it doesn't matter. Never mind. Okay, so anyway, that you can assign a value from your array to a particular variable if you want to. What else do they tell us? How do tell us to do here? Okay, so this one confuses people a lot. And it shouldn't. I hope that I can explain it properly. But let's go ahead and try here. If I do this, B, in parentheses, and I put the colon operator, and then I do a comma, and I do 2. What does this? Let's do 1. This is going to extract something from B. What is it going to extract? What did it extract?
first row. or first column?
The first column. Now, thinking of it that way is the thing that confuses people. That's exactly what it did. But I would prefer that we think of it as still the first thing is rows and the second thing is columns. So what this has done is it's taken B, and the colon means all of the rows. So it's taken all of the rows and the first column. Okay? Now, I don't know why it confuses people, but it does. So I want us to think this way. Colon means all of the. So if it's in the first spot, it's all of the rows. And then the first column. So this is row 1, row 2, row 3, row 4, first column. So of course, if we want the first row, what do? We do B, 1, colon. Right? And we get the first row. If we want the third row, we replace that 1 with a 3, we get the third row. Right? And this, again, is another very useful thing because often we've organized our matrices so the columns are holding something and the rows mean something. And if we want to extract an entire column, we can do it very easily. It's not bad. You can also do things like this. You can say, let's let C equal 5 times B, the first row, so all the rows, and the fourth column. And what it does is it takes that fourth column, or all the rows, fourth column, and it multiplies all those values by 5 and stores it in C. Then, of course, I could concatenate on B this C and add some more stuff to C. How would I do that? Well, I'd make a new thing, call it Q equals, and we'll put it in square brackets, and we'll do B, comma, C. And it puts a new column on. Remember, columns give you new columns, and since C was a column, I could do B, which has its 4 columns, and add on another column, C. In fact, I could even do this. This is where it gets kind of funky. I could say that B is going to equal now B comma B. B comma B. I can actually reassign B to be something else using B. So this puts all of the columns in B next to all of the columns in B again and makes a new matrix B. Now B means something different. I can't go back and use B what it was because now I've reassigned it. Be careful doing that. Be careful reassigning a variable using itself because it can confuse your program. But it can be done and it can be useful. But just be careful doing it.
Can you undo or not?
In MATLAB, no. Well, let's see. Can you?
There's a UI undo, but I don't know what that is.
Yeah, you can. I don't think that you can do it in the command window. Because all the command window is all it does is it takes commands and runs them through MATLAB. It doesn't save anything, except, it does save variables to the workspace, but it doesn't save anything else. So I'm pretty sure you cannot. I think that if you could, they'd probably have a button up here for it. So. Okay, let's see.
Yeah.
All right, let's see. Here they give a little thing I've never seen before. This is new to this book as far as I can remember. The bottom of page 123, they say you can use the word end to identify the final row or column in a matrix, even if you don't know how big it is. But of course, you can figure that out using the length or the size function as well. It's just, I've never seen that before. That's kind of interesting, I guess. All right, so we have this example using the temperature data, which I know, I'm trying to remember that, no, that's not in MATLAB. So we can't extract that easily. So the next section I'm going to go ahead and end at this point. My voice is really starting to give out, and it's harder and harder for me to push my voice louder. But we'll come back next time and we'll learn how to use what is called mesh grid, which is another thing that confuses students a lot. And hopefully I can explain it in such a way that you can visualize it. It's just a way, really what it is, it's a way of combining matrices, and it's used a lot in making three-dimensional drawings, three-dimensional images. And so some people confuse it with some kind of plotting feature. It is used a lot in plotting features, but it's not a plotting feature. It's just a combination. It's a way of aligning and putting matrices together that have relevant and related data. But anyway, we'll go ahead and end there. So you've got enough to kind of get started with Chapter 4. You should be able to finish Chapter 3. So the homework's from those things. Once again, if you have any questions for me, don't hesitate to email me, send me your code, and I'll look at it. I've already had a couple people do that. Before I leave, does anybody have a question that I can answer over the ITV? Have a question that you need to answer here? Need answered here? We're all good to go? Okay, well, if that's the case, have a good week. Make sure that you do your shared document entries. Make sure that you turn in your class notes. And have a good week.
Yeah.